Okay, so I'm going back to number 107A, and I'm answering number 109, which says classify each of the reactions represented by the chemical equations in questions 108, which also refers to 107. So 107A, ammonium phosphate, and I already worked this one out. I wrote down the skeleton equation and then I balanced it out. So here's the final product of that. But now the question is to classify it. Do I have a synthesis, decomposition, single replacements, double replacements, or combustion? Now I don't have combustion because I don't have that molecule that always tips me off, being oxygen. Remember, combustion reactions typically require oxygen. I don't have that here, so I know combustion I can already go ahead and mark off. But if I look here carefully, I have, on my reactant side, I have ammonium, which is a cation, and I have phosphate, which is a anion. And then I have another cation in chromium, okay, and this was a +3, and then my anion in bromine, okay, which is a -1. So take notice on the product side. I still have my bromium, and I still have my phosphate, my two cations. I'm sorry, my two anions, my negative charges. Now, if you look at bromine, for example, bromine has a new dance partner here. It no longer has chromium, okay? It now has ammonium. So ammonium switched from phosphate to bromium, and chromium switched from bromium to now switched over to phosphate. Okay, so I essentially have two players that switched. Okay, so that means I have a double replacement. Okay, remember, in a double replacement reaction, you're going to have your cations switching places. That's all that happens. Your cations switch places. So ammonium now goes with, let me write this in a different color. I'll pick orange this time. My ammonium has now switched places and gone over to bromium, and my chromium now is with phosphate. Okay, so that's all a double replacement is. A double replacement is, once again, my cations switching places.